All right, so we're going to move on to rational equations where the variable appears only once. There is a step to rational that's kind of funny to word with our reverse order of operations, but I don't think it'll throw us too much. So looking at what's happening in this first one, and don't mind my write-in on the second one, I apparently was getting ahead of myself and doing examples that really should go in the next section. So I'll try and remember to fix that on your print off. Okay, so what I see going on here is first the division and then the subtracting 3. And what's a little funny about this is we can't say that we're applying the operation of division to m the way we would in other equations. Oh, m is divided by 2, so if we multiply by 2, it gets rid of it. It's not so easy here. 2 is being divided by m, so dividing out of 2 isn't going to do anything to get m out of the denominator. So let's go ahead and do the first step because it's not weird, and then we'll look at that one. Subtracting 3 is the last thing happening, so the first thing I want to do is add 3 to both sides, and I get 2 over m is equal to 14. Okay, so the funny step here is how do we undo the step that puts m in the denominator? We could think of it as like a reciprocal step. And there's more than one way to think about this, but the one that I think will work for us in any sort of equation where the variable's in the bottom is multiplying both sides by that m, because what will happen is we're dividing by m. How do we undo that? We multiply by m. And while that did maybe create a new operation for us to deal with, m is out of the denominator, so I still like it. It's a little bit different than our thinking on linear, but I think it's still a great step. Okay, this did create now a multiplication by 14, so while we didn't originally have that one listed, we'll have to deal with it now, which means that m is equal to 1/7. So we're reducing that fraction. 2 goes into 7, or 2 goes into 14 7 times. The one big thing I want to warn you about here is we've listed our properties of equality, and our properties of equality say you can add or subtract anything you want as long as you do it to both sides. You can multiply or divide by anything as long as it's not 0. And there's a funny thing that happens in a problem like this where you multiply both sides by the variable because we don't know the value of the variable. And actually, let me say this really carefully. It's not just multiplying by m. If we were going to multiply by m plus 2 or 2m minus 1, if you multiply by something with a variable in it on both sides, you have to be really careful because you don't actually know whether or not that thing is 0. So in the end, if it turns out that it is, that means everything you've done is invalid. So what I would just say is if you multiply both sides by something with a variable, let's say by an expression. Oh, I didn't leave myself room. Expression, I-O-N, with your variable. You may introduce an invalid solution. And we have an official word for this. This is called an extraneous solution. So mark that one down for yourself somewhere, and just remember as you're working that if you've multiplied both sides by something with a variable, you have to, this isn't like before where you're checking to see if you made a mistake, you have to check your answer. You're checking to make sure that you didn't introduce that bad solution. The good news is it's often very easy to spot whether or not you did. The only problem we could possibly have was if we multiplied both sides by 0. So we would only be worried if m was equal to 0, and it's not, it's 1/7. If m was equal to 0, we would throw that away and just say we don't have a solution because that is not valid. And in fact, you don't even have to go back and look for the step where you multiplied by something. You can just go back to this original statement of the problem and you can say, okay, well, if m is 0, then I'm dividing by 0, which is never valid. So as long as your solution isn't making the denominator you started with 0, you should be in good shape. So watch for them. I don't anticipate you'll see a lot of that in this section, maybe not any, but you will as we continue to get messier equations. Okay, so let's look at one more rational. You can ignore that last one. We're not going to do that until the next section. Same idea. We want to figure out everything that's happening to z, so everything on the right-hand side that's being done to z. So I can see, let's see, the fraction bar is a grouping symbol, so I'm actually going to worry about first the addition, the adding 4. That's the first thing that I would say. Well, maybe the second. Really, this is kind of a funny one. I would say, oh, control. Let me put that back. That was my hiding of my old thing. Ooh, maybe I can't put it back. I made it mad. There we go. Okay, so this is that funny business where really what we're looking at is negative z plus 4. So I'm going to go ahead and call it out this time. It's really the negative 1 is the first thing happening and the adding 4 is the second thing. And then the third thing happening is this division, which again is kind of the weird one because it's not that we're dividing z by something, we're dividing something by z. But still, that is the third thing happening, and we'll deal with it in the same way we would order-wise. Last thing happening over here, again, you can think about the multiply by negative 1. It doesn't really mess you up if you don't think that way, so I'm just going to say that that adding 3 is the last thing happening. So the first thing I want to deal with is that adding 3, which means I will subtract 3 from both sides. Now you take the last thing and you reverse it, which is going to leave me with 3 equals negative 5 over 4 minus z. I guess I don't really need those parentheses, but they're not hurting anything. The second to the last thing was the division. So I'm just going to mentally hook this negative sign to the 5. Remember, with a negative sign out in front, you can move that to the top or the bottom. The only thing to be careful about is if you move it into the bottom, you need to distribute it. So if I want to undo this division that put my variable in the denominator, I would do it by multiplying inverse operation by 4 minus z. Almost, my leggy pen. And that's going to leave me with 12 minus 3z. So this is just distributing in. And on the other side, the 4 minus z should cancel. I'm multiplying and dividing by the same thing. And all I should have left is negative 5. So we do have to do a little bit of reevaluating at this point. Since I distributed the 3 through, you could actually leave it if you want. And then I would say the subtraction, the adding 4, subtracting, whatever you want to say, is the first thing, and then multiplying is the second. By distributing, I actually change that up. The first thing that happens is the multiply by negative 3, and the second thing that happens is the add 12. So we'll subtract 12, and we will get negative 3z equals, there we go, negative 17. Man, this pen is killing me tonight. Okay, 17. And then final step, we're multiplying by negative 3. To get rid of that, we'll need to divide by negative 3. So we get z equals 17 over 3. Again, we have to be thoughtful about this. The step where we multiplied in our variable, we can only do that if what we're multiplying by does not equal 0, which means it's not okay for z to equal 4. And it is possible that when we work through all of this, that's the solution that we'll get. We didn't, we're in luck. It's safe to plug in 17 over 3, but 4 would be bad news. And once again, if you'd like, you can go all the way back to the original statement and just say, okay, if I have 17 over 3, does it make any denominator 0? And it does not. Only 4 would make the denominator 0. So you can catch that from either spot. Okay, so that's the beginnings. We'll see a lot more of rational equations when our variable's appearing more than once, but I wanted to get the beginnings of it here. Thanks for watching.